All right, let's review. We're starting chapter 9, so let's review a couple things before we jump into quadratics, one of my favorite chapters. Loving the quadratics. You spent a lot of time already doing linear. Remember, linear makes a line. Quadratic makes a parabola, or a U, which you're going to learn a lot more about. Wait, and you've already kind of set the foundation for it in the last chapter, solving them and stuff. So, or factoring, I mean, you didn't solve it. So what is a function? Let's just get that back down here so we know. It's a relation in which every domain, which again is what? Yep, the x values, is paired with exactly how many? Yes, one range value, which is which one? The y, yes. And the vertical line test, what is that used for? It is a test to determine if a graph is a function. So remember, you could draw the vertical line straight down through any part of your graph. And if it hits your graph in more than one spot, it is not a function, because then that implies that there's hitting it in more than one spot. If you draw a vertical line anywhere and it can only hit at most in one spot, then it is indeed a function. There is a fruit fly attacking me. Why was that the case? It must have come out of my flowers. I have beautiful flowers sitting here, Valentine's Day flowers. Anyway, what graph do you get for a linear function? I just said this about 1 minute ago. Answer? Yes, line. What graph do you get for a quadratic function? I also said that. Yes, parabola. And a parabola, spell it correctly, looks like a U. So let's review, since you've done a lot with linear functions and quadratic, I want you to kind of see the difference between the two. So I'm going to slide this up. I hope you're able to get everything down and focus on these two. So here is standard form. We talk about general standard form. And so for a linear function, we might see something that looks like 2x plus 3y equals 10. Or y equals 6x plus 7. And you guys would plot the y-intercept at 7 and then the slope rise 6 run 1. You're kind of familiar with that. In a quadratic, here is the standard form. And the reason it's a quadratic is you notice the x is just x to the power of 1. Now x is to the power of 2. So it's specifically this right here that raises us into the quadratic. Okay, so we did a test earlier to determine if it was a linear equation. And I wrote it all out here already. We took coordinates. We put them in our xy axis. And then we looked over here, what's the difference? Plus 3, plus 3, plus 3. Okay, so that side is consistent. We have to check this side. -1, -1, -1. That is also consistent. They don't have to be the same, but my answer is yes, it definitely is a linear equation. Well, there is a way to also check this with quadratic functions. So let's start off the same as we did this. We have to do what we did here first, and then we're going to do one more thing. So let's get going. -2, 6, -1, 3, 0, 2, 1, 3, 2, 6. Thank you, Birdie. All right, so we need to check the left. We're going down 1, down 1, down 1, down 1. Okay, let's see. Maybe this is a linear. Let's check. -3, -1. Already we know it's not. +1, +3. So right there we know not linear. That's all we know. Not linear. But what we are going to do is called a second difference. I want you to highlight that. You're going to use that. It means this was the first difference right here. You're going to repeat it with the numbers that you got. So we're going to look between those two now, from -3 to -1. What happened? +2. What happened from -1 to +1? +2. What happened from 1 to 3? +2. Ding, 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 ding. The second difference is the same. That is our second difference. My answer is yes, it is a quadratic. That's how you can tell. So it's very similar to this, but you have to go one step further. We wouldn't here because we knew it was linear when we got there. So sometimes I'll give you points and say, you tell me, is it linear, is it quadratic, or is it neither? So you have to do these checks. If it lines up here, linear. If you have to go one more step, and it's the same, quadratic. And if these aren't the same, it's neither. So tell whether each one is a quadratic. Well, looks like we have to line that one up. So let's get to work. I'm going to let you try to do that. I recommend you stop the video and try it yourself first. I just have them all lined up here. Difference here. Oh, it's +1. +1, +1, +1, check. +7, +1, +1, +7. Not linear. Check the second difference. Down 6. Nothing. Up 6. No, no, no. Not quadratic. And this one tells you it's not linear. How about this? Is that a quadratic? Focusing in on this right here. Nope. Not quadratic. Class, what is it? Right, it's a linear. How about that guy? Yep. So you could get it in standard form. So notice standard form. You know, if you solve it for the y, it's up here, and the solving for the y is the slope-intercept form right there. We could just move that over. I don't think you really need to determine, but let's just do it for good measure in case you have a problem that says, get it in standard form. Well, there it is. It's in standard form. Is that a quadratic? Yes. How do you know? What's the trigger point? Right there, that guy. X squared. I shouldn't say the squared. It has to be the x squared. Yes. All right, so now turn the page. We're going to look at a different type of thing here. We're going to look at using a table of values to graph this. So we're going to talk about graphing quadratics now. When you graph, you're going to start off today using an XY chart, like we started with linear equations using an XY chart. And then we eventually figured out that, remember when you used to do linear equations, you used to make an XY chart and plot them and connect them. And then we learned how to use slope-intercept form, where we could plot the y-intercept and the slope. So we learned a shorter way. Well, we're going to start with this first, where you plot coordinates so you get familiar with it first. And then as we learn more, there's going to be a little bit easier way to do it. So let's first remember that when we have an x squared, we want to include some negative values in there. And I see a 3 in the bottom, so do you guys remember what I said about picking values? I want to pick values that are going to cancel off at that bottom one. So I'm going to pick multiples of 3. So I'm doing -6, -3, 0, 3, and 6. Instead of -2, -1, 0, 1, 2, because I want them to cancel off with that, so I don't have a decimal or fraction. You could, that's fine, but let's try it now. If you do this, y equals 1/3, and again, I said to put this in erasable, so put in the -6 here. -6 squared is 36. 1/3 of 36. Remember, that's where you can cross cancel. So 1 and 12. My answer is 12. All right, how about -3? -3 squared is 9. So you have 1/3 of 9. 3. Put a 0 in here. 0 squared is 0. Times that is 0. Put a 3 in here. 3 squared is 9. And it's going to repeat, right? Because when you squared the negative, you got a positive 9 too. So these are going to be the same, 3 and 12. Plot them, but I can't go by ones. No way, no how. So I am going to go by twos. So 2, 4, 6, 8. -2, -4, -6, -8, 2, 4, 6, 8, 10, and 12. I think that's going to work. -6, 12, so go over -6, up 12. -3, 3, so -3, 3 would be between here and then between there. 0, 0 is right here. 3, 3, go over 3 and up 3. And 6, 12, 6, 12. All right, now that is not a V. Please do not try to draw straight lines. They are not a straight line. No way. Okay? The slope, the slope isn't the same here. This is a U, so I want you to do your best, and if I can do it pretty decent, I know you can too. But all I know is I don't want to see a V. I want to at least see that you tried to curve this bottom, okay? Next one, let's try some new ones here. Because there's no fraction in the bottom, I can do the original -2, 0, 1, and 2. You're going to want to use 5 coordinates for parabolas. All right, so y equals -4 times what squared? Let's put in -2. -2 squared is 4 times -4 is -16. Okay, put -1 in. -1 squared is 1 times -4 is -4. 0, 0 squared is times -4 is 0. 1 squared is 1 times -4 is -4. So you notice it's becoming the same again because of the squared. Doesn't always, got to be careful, but 2 squared is 4 times -4 is -16. Again, I cannot go by ones, or it's not going to fit. 2, 4, 6, 8. -2, -4, -6, -8. -2, -4, -6, -8, -10, -12, -14, -16. Okay, there we are. So -2, -16. Wow, this is going to be a really sharp curve. -1, -4 is right here. Let's use a different color. Right here and right here. And then 0, 0 is here. And then 1, -4 is here. And then 2, -16 is down here. So that's a very sharp curve. All right. There you go. Yours probably looks better than mine. Okay, now we're going to start learning about more about these parabolas. You've learned how to graph them, and now we're going to notice some things that you can tell from looking at them. I want you to box highlight your standard form for this. That is going to become kind of like y equals mx plus b for linear. This is going to be it for your quadratics. That's just etch that right in your brain forever and ever. So you can actually tell by looking at an equation if a parabola is going to open up or not. And when I say that, I'm saying here, this one opens up, this one opens down. Well, guess what, folks? If A is greater than 0, it's going to open up. So if the number before the x greater than 0 means positive, it's going to open up. And it's obviously then likely, what do you think is going to happen to make it go down? A is going to be less than 0. Okay. So let's look and see if that's true up here. The A, what's the value before the x squared? It's 1/3. It's a positive number. Goes up. What's before the x squared? It's a negative. That's why it's going down. Okay? It was not the number, it was the sign before it. And the sign before the third is a plus, right? That's what told us it went up or down. And you might say, well, what about when it's 0? What about when A is 0? Well, let's think about that. 0 times x squared plus bx plus c. What happens if A is 0, class? What happens? What's 0 times x squared? It's gone. You're back to a what kind of line? Equation. A linear. So for a quadratic, A will never be a 0 because it drops it out. All right, now looking at the bottom, I want you to practice that. Look at those two. And again, in order to determine this, you have to have it in this form. You have to have it in y equals ax squared plus bx plus c. You can't have them all mumble jumbled up. So when we look down here at this, we can see it's mumbo jumbled up. We don't have the y alone. So we have to solve for the y. So what are you going to do? Yes. Add 1/4 x squared to both sides. Can you combine an x squared or an x or a -3? Absolutely not. Those are not like terms. So there we go. There is the equation and written in the right form. Can you now determine if it goes up or down? The answer is, I'm looking at the sign before the 1/4. Oh, there is no sign. What is it? That's right, it's a plus. So therefore it opens upward. Hopefully you had that. Because the A is greater than 0. And in this case, A is a 4th. All right. How about this one? Well, first of all, let's write it in the proper form. So I'm going to rewrite these terms. They're on the same side, so I'm not moving them. Okay, I'm just rewriting them. So I'm going to put the -3x squared first, and then the 5x. So I get it in the right form, and now go ahead and evaluate. Going to do what, class? A is a -3. A is therefore less than 0, so it opens downward. So basically the sign will tell you what you were doing there. Okay, still got a couple more things. This section is loaded. We're going to talk about the different parts of the parabola now. And if you notice, there's several terms up here. So the first one we're going to talk about is vertex. I want you to highlight these in the same color. Okay, so when we talk about the vertex, we're talking about the point at the very tippy top or the very bottom. So in this case, it's a -1, -1. It's a coordinate. The vertex is a coordinate. Okay, so what's the vertex here? Zero, 5. And the next thing we're going to talk about is minimum and maximum. Okay, you're only going to have one. Okay, so you pick one. It's either minimum or maximum. You can't have both. And it's basically you're looking at where that vertex crosses and you're saying, what is that? Is that point the minimum of the whole graph, or is that point the maximum of the whole graph? So again, you're looking at that. So I draw a line right through it. So again, I'm trying to color code it so when you're looking at this later, you remember that we're figuring this out. So is that, my daughter's cooking in the background, a delicious meal, so I'm sure you're hearing that. What is the point right here? Is that a minimum or max? It is. It's the minimum of all the points that go forever on here. They're all bigger than this one point. So I'm going to circle the minimum because again, it's only pick one. And then now you tell me what it is, and it's where it hits the y. So what coordinate is that? It's -1. So you write -1. You don't put a coordinate to that one. It's where it hits the y when you extend it over. And over here, is this point the minimum or maximum? All right, it's the max. So circle the max, and because all the other points fall directly below it. So what is that max? It's 5. Again, you don't put a coordinate. You just put the number that it hits the y, where it hits the y-axis. When you draw a line across. Okay, domain and range. I'm out of highlighter colors. I need some of you who have 42 different highlighter colors, but I do not have them right here. Domain and range. Okay, so domain and range, you remember domain is your x values, and range is your y values. Well, here's the really good news. The domain is kind of easy for parabolas that are going up and down like that, because these parabolas go on forever. Even though it looks like it's gonna eventually go straight up, it doesn't. It slowly still keeps going outward forever. And same on this side. So when you're talking about the x values, it doesn't matter where you pick on here. When I draw a vertical line down, it would hit it. Even way over here, it's gonna hit it. It's just gonna hit it way off the graph, up off the page. Okay, so all real numbers is the answer for domain for parabolas in general. Only in a real life situation when it might be restricted to positive values or something in the first quadrant would that maybe change. Okay, if it's just a straight up parabola, again over here, it doesn't matter where, this is going to continue, all keep going out. So no matter where I picked on this line, eventually, even way over here, if I extend this line way over here, I go down, I'll eventually hit it. So again, it's all real numbers. Now the range is where we are going to, you can see there's infinitely many points, right? Everybody knows that. There's one vertex point here, but there's infinitely many going forever off of both. So we're going to use an inequality for our range. Okay, because I can't just say the values. There's infinitely many of them. So this is where you're going to use your ruler again, and you're going to go up until you see the bottom of that line. Where does it hit the y-axis? Because range is y. It hits it over here at -1. So I'm going to say then that it's all y's greater than or equal to -1, because I started here, I went up till I hit it, and then it keeps going forever. How about over here? Well, where does it start? It starts up here now. Here's my y. And then it keeps going forever down. So what is that value? That's 5. So now it's going to be less than. See, this was bigger than. This one is less than. So its y is less than or equal to 5. So let's practice. Let's practice. That's a lot of information there. So let's look at these. Identify the vertex of each parabola. If you forgot what vertex is, look above and remind yourself the vertex is a coordinate at the tippy top of your parabola. So see if you can do that. Yep, so it's right there. And so that would be 1, 2, 3, 1, 2. So negative 3, 2. Hopefully you guys didn't miss the negative. And is that point the minimum or maximum? Circle which one you think it is. Correct. It's, oh, yes, I almost thought I circled the wrong one. The minimum, that's the lowest value. And what is it? Remember, you pick one, and we did, and it hits the y-axis. So I have to see, where does that point hit the y-axis? Oh, it hits it right over here at 2. So my minimum is 2. Can you try for this one on your own, please? All right, the vertex again is right here, and that looks like it's at, goes over 2 and up 5. Is that a minimum or maximum? Right, it's the top of the parabola, so it's a maximum point. Every other point on it falls below it. And now, what is that? So again, that's where it hits the y-axis. So you look over here, and it's at 5. Now we looked over here on this one, and it was 2. That's how we got the max point. All right, last problem is practicing the domain and range, since that wasn't up here. So if I asked you for the vertex, you would say this point, and it would be 1, 2, 3, 4, negative 5, negative 3. And if I asked you for a min or max, you'd say that's a max point at negative 3. But now I'm asking you for domain and range. So the x values. So remember, x is holding it this way, and no matter where I put this line, I know that if I went far enough down, I'm going to hit that parabola. So the domain is all real numbers. Again, I hope you stopped it so you could do this. And the range, you have to find, are you going up or down, or going down? So we're putting this at the bottom of that. And everything falls below it, right? All my y values would fall below it. So what is that value over there? It's 1, 2, 3. Actually, it's negative 3. So that means that y has to be what? Less than or greater than? Right, less than or equal to a negative 3. All right, there's a lot packed in there. You're going to need to keep those notes with you close by when you're doing your homework. And I will see you on the next lesson. Bye.